All right, well, thanks everyone for coming out. This will kind of act as just our quick training for this secondary clarifier number 2 out at the plant. You know, really a lot of this comes down to questions. I mean, clarifiers really aren't very complicated. I mean, really you have the main drive unit, and that's the primary concern as far as maintenance goes. So really, if you have any questions, please stop me. Let's talk about them. Let's go through them. But a lot of this is going to be derived off questions because there's really not a whole lot of information to say otherwise. So here's our drive unit. It's our pretty standard one. Yours looks pretty close to this. It may not be exactly like this. It looks like this might have a triple reduction. Yours out there, I believe, only has a second or 2-stage reduction versus a 3-stage. Really, that doesn't make any difference other than just what the output speed is down at the bottom. So pretty simple. This right here kind of goes over some of our just standard parts. You know, we have our precision bearing, the lower pinion bearing, the housing. The housings are all out of fabricated steel. They used to be out of ductile iron, but that can get brittle over time. As we saw on clarifier number 1, I believe it was out here, that had that failure. It broke and the ball bearings were showing. So the cast iron can get brittle over time, and when it does tend to break, it tends to break kind of in that fashion.
So you say fabricated steel, so is that carbon steel?
Yes, yeah, it's fabricated carbon steel. The housing, instead of being cast all as one piece, is just welded, rolled and welded, and there is some pieces that are, you know, formed in one big piece, but it's just out of A36 steel, and then the various parts are welded. The precision bearing is kind of a staple of WESTECH. That's how we've been doing our drives for 40 years. It gives a locked raceway, really helps to be able to distribute the stresses from the hanging weight and the overturning moments properly back into the drive. And it really adds for added life. You know, when you have strip liners, a lot of the time you'll get unbalanced loads that run on these ball bearings, and sometimes you'll have 3 or 4 bearings that will get all the weight, and just because it doesn't distribute properly. So having this precision bearing, it kind of locks everything in and causes it to be able to distribute those loads a lot better. The torque box, this is kind of an older style torque box that you probably saw on the old one that they removed. The newer ones look very similar, and I have an up-close picture on the next slide. You have the coupling and cycloidal reducer. Those are pretty simple. They're not really anything too fancy. The cycloidal reducer, sometimes older drives will have a worm gear there. It's basically just taking an 1800 RPM motor and reducing it down to the final output, which in most cases is like 0.04 revolutions per minute. That's why clarifiers go so slow. Is usually because of that reducer. This right here is actually a picture of a load box, and this is actually pretty identical to what you have out there. Some of the most important parts are going to be these limit switches right here. So these limit switches here are what controls the alarm and the shutoff. So this is what really makes a great thing, because it used to be that these micro switches would have issues and would stop working or wouldn't transmit right, and then you have no protection on your drive unit. And you want to make sure you have the protection. You know, we've heard stories of ladders falling in the clarifiers, even deer jumping in there and causing things to torque out in the middle of the night. So, I mean, these are definitely good things to make sure you keep. These switches are actually really simple. There's just a little. I wish I had it right here. You can see this little arm right here. At the end is just a roller, and that roller contacts this flat plate right there. And once that roller hits a certain point, it just shuts it off. Works pretty simple. They don't require any maintenance. It's actually really ingenious. This right here is the rod, and one of the things that we're going to ask the maintenance staff does is weekly they go out there and they push this rod. So this rod right here and this rod are connected to the main spring. Now our cycloidal reducer, if we come back here, right here there's a plate. We call this the torque arm plate. That plate touches a little spring underneath. It's actually inside this box right here. underneath the torque box, and that spring is calibrated to be able to measure the torque. So, 5 pounds out there translated all the way across is X amount of torque, right? So this, as this spring and this arm distance right here, it's what's reading the torque. So there's this little red out here on this side, and it's kind of covered in sand in this picture, but there's a red button right there. And the one thing is we want you to spray it with WD-40 just right there to make sure we keep that thing lubricated weekly, every other week, whenever you're out there and think of it. It's not hugely important, but we don't want that to bind up, because if that binds up, you're not transmitting the correct torque. If it starts binding up, you could actually be transmitting more torque and it's not moving the way it should be. So it's only reading 20%, but really you have 40%. Or, in some cases, we've actually seen where they've never done this, and these things freeze up completely. And I've actually seen one plant that welded past it. They welded this rod to this brass rod, which pretty much didn't allow any torque reading to go through. So they had no torque protection. So we want to make sure we're watching these and we're being careful, because if this breaks, this is probably one of the first things you want to get replaced or looked at or recalibrated or whatever. This is hugely important in protecting the drive unit from reaching those high torques. Now, with that being said, most of WESTECH drive units are designed for twice what they're actually going to see. So if this one was seeing 10,000 foot-pounds of torque, we've actually designed it for 200 foot-pounds or 20,000 foot-pounds of torque. So most of our drive units are double designed. Same with our new mechanisms. This mechanism back in '89 when it was put in would have been designed for that same double the torque, the continuous torque. That's just our life.
Is that when you bought the last unit, 1989?
Yes. So all three of these units were done in 1989. So, yeah, they are getting pretty old. But new drive units, you should probably, I think I heard you wanted another 15 years out of them. However long you can get out of them, right?
Yeah.
So as long as you keep corrosion down, that's really your worst enemy.
We got, 23 years of service out of the last one then?
Yeah. The drive units are designed for 20 years of continuous running. The bearings are, but we have some units that are running 30 years plus. So it really just depends on maintenance and comes down to how much wear and tear they've actually seen over their life. So, any questions on this stuff? Okay. So safety, these are all pretty no-brainers. I mean, you want to make sure that only people who are supposed to be out there are working on it. That you're being careful around moving parts, especially really your main moving part is going to be where this direct coupling is at, up here between the motor and the cycle reducer. There'll be a Lovejoy coupling in there with a spider type fixture, and that will be moving, but there is a cover over it, so take care when you pull that cover off. Be careful, you don't want to get your fingers caught in there. It is rotating about 1800 RPM, so it's moving pretty quick.
But you wouldn't be going in there unless you had locked it out.
Correct. Yeah, correct. I mean, there is a grease zert right underneath for the cyclo. That's right there. That gets grease in that top part of the cyclo. So, you want to be careful if you're pumping grease in there. So, but usually, I mean, turn it off for a few minutes, pop that in there, and grease it. The cyclo has a sealed housing, so you shouldn't have to really be greasing it a whole ton, but especially as it gets older, it can require more and more. So, obviously you want to put warning signs if you have something down, and so really WESTECH, we want to be careful with all of our equipment. We don't want anyone to get hurt. So I think common sense pretty much sums up a lot of this. And you guys have had WESTECH equipment for 23 years, so I don't know. Really, there's not a whole lot different between then and now. So, startup, we like to just kind of go over a little bit of the startup stuff, and mostly, it's being familiar with your equipment and your process, making sure that you understand what's before and after, and all those things. And it's really not the biggest thing is making sure that the mechanism is lubricated. Make sure that the drive unit's full of oil and that there's been grease placed where it needs to be, especially while things are still dry. Once you get water into the tank, most of the mechanism will get a little bit of lubrication just from the water, but the drive unit with the oil, making sure the condensate is out, that's important. You want to be familiar with your piping. So on these ones, for example, they have the rotating skimmer pipes. So you want to be careful of those, making sure that nothing's hung up on them or broken. You're watching those. You want to make sure, so this one right here, rechecking the mechanism and assembly performance during several revolutions of the arm. So, and it's on another slide, but we always recommend taking down the mechanism once a year to look at it. You want to look at the paint. You want to make sure that if there's any areas you need to touch up, that you're touching those up. You want to look and see if anything's bent. I mean, these mechanisms can take a lot of torque, and sometimes they can bend metal without ever tripping something out, or if something gets caught, you never know. Like I said, I've seen pictures of deer floating in the tank and ladders and all sorts of stuff. So even some people swimming. I heard a story once of this place out in Kentucky. They actually had people going out there and hanging on their skimmer arm. They thought it was a pool. I mean, if that's what they want to do, fine. But I mean, it looks like you guys have things pretty well gated off and that. But that is always a possibility. And then let's see. Let's go. Yeah, going back. So you want to fill the clarifier with the effluent. You want to start it. You want to watch your sludge blanket. Obviously, make sure those things like that. You guys have probably done this hundreds of times. So really, having the mechanism turning and filling will be helpful. You want to make sure that things are moving smoothly. Nothing's binding or jerking. That you're not getting high torques as you're filling that up. That could be an indication for something else going wrong. That's also a good time to kind of watch some of your seals. Make sure that as they fill up and get a little bit of pressure behind them or head, they're not popping or moving or anything else like that as you get going. Let's see. So shutdown. Like I said, approximately 1 year after the clarifier, we recommend you taking it down, checking paint, checking everything, and then also checking the bolts. That's kind of important as well. Checking the bolts. You want to make sure that those bolts have stayed torqued. So whenever we install a mechanism, we give the contractor a certain torque value that all those bolts should be. Any vibration can cause those to come out, cause them to loosen up. You might want to double check them, especially the drive bolts. That's where a lot of your torque is going through. And also like header bolts, the moving parts, main moving parts would be good. Let's see.
Tim, on that sludge arm,
Yes.
I actually looked at it with my last patients, but it was like one revolution, a little less than an hour. Do you know that exact number?
Yeah. It's actually, sorry. Back here in the drawings of the O&M, there actually will be where is it? It's the first drive drawing. It kind of looks like this. It's kind of not, the number is really long, but you want to look at that one. It's ending in 1205. That right there, right down towards the bottom, will say direction of rotation. So this one is 0.003 RPM. So that's how slow it is going. So you times that by 60 minutes.
Where do you see that? 0.00.
So right here, direction of rotation, right down to the first crease, so that very last. So that's what this motor has been designed to do. One more.
One divided by 20.
Take that.
Go back a couple more pages. So that tells you exactly how fast, and that's per minute. So you times that by 60, that'd be the revolutions per hour, which I think would be.
So one revolution is 33 minutes. Does that sound right?
Yes. Yeah.
Okay.
Yeah, that's about right. And that's usually pretty typical. I mean, the 10 to 6 feet per minute tip speed is pretty general for a secondary or primary. No, actually probably secondary clarifier. Primaries are generally a little bit faster. But anywhere between 8 and 12 is usually where we see a secondary. So So preventive maintenance. Weekly, we want you to check the drive oil and the drive condensate, and then also apply WD-40 to the torque plunger. The torque plunger is that little red thing I was talking about on the side of the torque box. You want to make sure that stays moving freely, because that's what's transmitting your torque up to your switches. So, just from the outside right there's a little red cap on it. Spray a little WD-40 around that, and then also underneath right there, maybe hit a little bit. I wouldn't spray it directly in the torque box. We'll come back. So I wouldn't spray it inside here, but if you could get some around this part, and that also if you can fit some down in this area, that would help that spring just stay moving, fluid. If there's any sand or dust down in there, hopefully help wash that out and keep things going. So.
Who does that? Is it your staff or?
So, and then also the drive condensate. We say weekly on this drive condensate, but really it's going to be hit or miss. Some places that have a lot of humidity, like back east, Alabama, Florida, they get a lot of drive condensate because the temperature change and also the humidity in the air. So that is where we say do it weekly. You got to kind of judge it on yourself, and you'll be able to see the water in the sight gauge. I mean, you'll be able to tell if there's a lot of condensate on there. So the first couple weeks, I'd keep an eye on it, see how much condensate. If you're draining out a ton, maybe there's not any. Maybe you only need to do it once a month. I don't know, but as a general precaution, we say once a week. So it's always good to keep an eye on that. Monthly maintenance, you want to check out the skimmers, the neoprene, especially on this one where you guys have a lot more neoprene and plastic than what we would normally see in a normal skimmer, because you have the ducking skimmers. So you have 25 feet or whatever it is of neoprene and plastic there. So you want to check those. You don't have a flush valve, so you can ignore that part. The annual maintenance, we always tell people to send their oil sample for analysis. If you send that out, it kind of helps you understand what the wear is on it, if it's okay, how much longer you can do on it. It gives you a lot of information that can be really helpful. Like I said, you want to drain and make sure you tighten all those bolts. You want to look at any of the neoprene down along, the seals around the suction header and the manifold. See if you need to replace any of that. You want to inspect the seals, like I said, coatings. This is another big one. I know you guys just did a whole big paint job on this. So you want to keep an eye and make sure that any areas that have flaked off or been hit or are missing, you touch them up. Rust is going to be your enemy for this steel. If you can keep it rust free, you probably, like I said, you can probably get another 25 years out of it, or however long. I mean, that's hugely important to keep the rust off. And then, sampling should be done as often as necessary to maintain the quality. So how much ever you guys want to sample it is up to you. Emergency procedures, obviously remove the feed. You want to cut off the feed, direct it to another clarifier. If possible, allow the mechanism to continue running as long as there's no buildup of indicated torque. So, maybe let's say that something happens and one of your suction headers gets clogged or something like that. So it starts building up a lot of torque and then it torques out. But then you guys are able to clear the clog or whatever it is, and then you start removing some of that sludge. Let it run a minute before you pump back in raw sewage or raw influent. Make sure that's what it was. Let it run for an hour, 2 hours, a day, whatever you need to make sure that it's running okay and running smoothly. So if it's really heavy in the sludge and it keeps cutting out, it keeps cutting out over and over, you reset it, you restart it, that's probably when you need to drain it and you need to get it down in there and look and see what's causing it. Maybe you have something caught down there, I don't know. Could be anything. Troubleshooting, a lot of the troubleshooting stuff is in the O&M under 318, pages 3-18 to 3-20. That's in section 3, pages 18 and 20. If you have any other questions that aren't there, you can always call WESTECH. So I gave each of you my card, or there's more up here if you didn't get one. Also, my number's on the front of this manual. WESTECH has 24-hour people available to help you out if there's a problem. The person you talk to initially may not have the answer, but somebody can find it. We have people there that have been there as long as WESTECH's been around. So we can always help out, find the solution. If we have to, we can come out here, take a look at it. We want to be around to help out however we can, however we need to to make sure you're getting the best out of the equipment. So, and once again, always just use common sense. So if the overload goes off, don't just turn it back on and forget about it. Try to investigate it, see what's going on. So, and this bottom one is hugely important. On the torque box, there are stickers and all sorts of fun stuff that WESTECH puts on there, because we get all these calibrated in simulated condition. So we always calibrate these, and we always get these done in the factory. They're dead set. We don't want them adjusted in the field. So if you feel that something is up with your torque box, that torque box can always be removed and sent back to WESTECH to get looked at if something's broken. Don't try changing any of the switches without contacting WESTECH first and getting instructions, or having somebody come out and do it. The best way of calibrating those switches would be doing a torque test. But we have to be careful doing torque tests with older mechanisms, because of the old steel. We don't want anything to break. So just don't tamper with that. That will void any warranty that's remaining on the equipment. So yeah, don't mess with those. If you think something's wrong, call us. We'll go from there. Spare parts, section 1, page 11 through 15 talks about spare parts. Really, that spare parts list is a lot of stuff that's just kind of thrown back to you by our department. Really, on this, your biggest things are going to be your neoprene and your seals. Other than that, you really shouldn't need anything else. All those can be ordered from WESTECH. There's instructions on there, however you need to do it. Questions? So that's really all that I had prepared. I knew you guys have had this equipment. We had another one not too long ago put in place. So it seems like it's running good. I mean, yeah, concerns, thoughts, problems?
Just a question, just a startup question. We're obviously planning on starting up this clarifier soon.
Okay.
Our plan is to initially just fill it up with just utility water, just clean water, no solid. And we're going to run the equipment for a while.
Yep.
From a manufacturer's perspective, what's the reasonable amount of time to get representative read?
Most of the time on new clarifiers, I see about a week is what's specified by the engineer, that they want it to run with just clear water. Or effluent, just water pumped back in. It's usually what I see specified. Personally, I would say probably 3 or 4 days. I don't even know if it's that long. I mean, really, on this mechanism, the biggest thing that you want to make sure you watch is that your ducting skimmer is rotating freely, and it's not jerking or binding or causing, as it comes back up, that it's coming up smoothly. Sure. It's not banging and hitting and causing rake arms to wobble and stuff like that. So, honestly, I would say a couple days you'd be fine. I mean, but I do see it specified almost industry-wide a week. So if you want to follow what industry does, excuse me, about a week.
I want to be practical and still get a representative read,
Yeah, I mean, I think a week would certainly give you a good indication. After 500 hours, we do recommend that you change the oil. So a lot of that stuff, did I answer your question all the way?
Yes.
Okay, thank you. So, a lot of this stuff is also in this O&M. So sections 4 and 3 are all pretty important.
Do you want to take us through the tabs, just what
Yeah, certainly.
Section covers?
Yeah, certainly. So it talks about the equipment. So it tells you what your warranty is, some general precautions. You don't want to weld on it, certain things like that. This is pretty standard for most of our clarifiers. So there could be some stuff in here that doesn't apply directly to your clarifier. Procedures for ordering spare parts, the spare parts list. And section 2 is kind of the installation instructions. This is more geared towards the installing contractor, or if for some reason you guys have to take something out and replace it. It can be done that way. Let's see. Section 3 is the startup and operation. So this goes through a lot of the starting it up and what we recommend for all that stuff. Dewatering and shutdown, how you go through some of that. The torque control is obviously really important. The other thing is long-term storage. So if you ever decide to take this down for a while, refer to these long-term storage things. Let's say maybe one of the rate guards breaks and you have to replace it. It's going to be down for more than 4 months. They say 120 days. There's some things on there you want to do to make sure you keep the oil moving, grease moving. One of them is hooking it up to a motor to let it go, or power. Some way of letting it run for a couple hours a week. There's also, it goes over all the monthly maintenance, the annual maintenance, and then it has a Clarifier checklist. It's on page 3-17. That is really helpful to know kind of what to do, when to do it, kind of some instructions. Then it goes into the emergency and troubleshooting. Section 4 is mainly dedicated to the drive unit. So that goes through like your cyclo, what you have there, what's the recommended gear oils. It's on page 4-21. So I get that call a lot. What type of oil do we use? What type of grease do we use? This kind of goes through what we recommend. And also back here in the enclosure section towards the back, I think fourth, let's see, which drawing is it? Actually, you know what, I remember this one wasn't. No, where's that? So it's the drawing that starts with tag, and then it says 21938A. It's right towards the back. This is the same thing that's engraved on top of the torque box on the drive unit. It tells you what all of your lubrication is. So it tells you that the cyclo bearing, you need a 1 ounce monthly. The upper bearing, 2 ounces monthly. The main bearing, lower bearing, weekly, as required. And then the torque box plunger with the WD-40 or something like that, it tells you. Are you finding that? Go back. Back a couple more, back to the drive section. So this is actually engraved or laser etched onto the top of the torque box. So it tells you what the 4 areas are, it points to them, how much oil is needed, and then it also tells you there how much oil goes into your reservoir. So it's an estimate. It says right here that it's 3 1/4 gallons of oil goes into the main bearing reservoir. So, if you ever drain that out once a year or whatever it is, that's how much you need to buy. I think it only comes in 5-gallon buckets. So, but that goes through that. Section 5 is really just the manufacturer's information on the actuator. So that goes over pretty much everything you need to know about the actuator from a manufacturer side point, because we just buy these actuators directly out from ANCO. We don't really do any engineering or changes on them. We buy them out. So, and then chapter 6 is all the drawings, parts list, drawings, installation drawings, all that various stuff. So, any other questions, concerns? I know the actuator might be a little bit. The actuator shouldn't really require any maintenance that I recall. Anything major, it might require a little bit of grease here and there. That's why I provided that actuator manual. Take a look at that. Other than that, I think that's everything that I have.
Did you guys have a tank at your shop that you actually test the drives in?
So all the drives, we do a diesel fuel test on them. So we own our own drive shop where we actually fabricate all the drives. And in there, what we'll do is we'll take the main bearing and we'll fill it up with diesel fuel. And we'll use that to check to make sure there's no leaks or any areas where anything's coming out at. And we'll also run them there as well. We don't have a tank where we actually put any type of load on them or anything.
Okay, that's what I was asking.
But yeah, we do test them before we ship them out. Same with the torque boxes. We have an apparatus that we use to calibrate them all. So.
You're not going to be hitting oil, right?
Are we?
Yeah.
Yeah, that was one of the questions I was going to ask. Would that be helpful?
Because we're going to be heading out over there right now. We have a bleach delivery.
I'll leave it up to you guys to make a decision right now whether you feel get enough training here, or do you need to go out to the field?
It's exactly the same as Clarifier number 1. Yeah. I mean, it's exactly. I'm more than welcome to go out there and show you whatever. I'm here to help. But if you don't need it, I don't want to waste your time. It's really completely up to you. So I'm only here to help.
Personally, not really.
Okay. Yeah, I mean, it's exactly the same as Clarifier number 1. I know that when my other guy came out to do the training on the last one, that's where he did it at. So always can feel free to call me. So yeah, always feel free to call me, or if you have a problem, an issue, I'm around to help.
Yeah, I appreciate it. Yeah.
And I know that Clarifier number 3 will be the next one eventually, right?
Right.
So we'll have to keep that in mind and keep learning.
Yeah. On this clarifier number 2, we still had issue with. Help me out. What did we have issue with? It didn't line up perfectly, and then we had to call WESTECH, and we had to.
The flange bolts.
Yeah.
The
Can
drive.
we somehow avoid that?
And this is where it gets really hard with existing equipment. So we kind of learned on Clarifier number 1.
Right. We had
Right.
similar issue.
Oh.
I thought we resolved all that.
It looked like the bolt hole pattern was just slightly off.
I don't know exactly what happened. It's really hard for me to say for sure. Kind of after talking with Brian and with Mike, it kind of appears as if something was shifted by a degree or two, and that kind of just moved everything on the drive unit. I don't know for sure though. Certainly we don't want the errors. And on Clarifier number 1, we had all sorts of problems with getting the ducking skimmer mechanism onto the rake arm, right? That's where we had all the problems, was getting the ducking skimmer to rotate, getting it to bolt up there. So I took all the problems that we had on number 1 and fixed them on number 2. But with the drive unit thing, I don't know how we could have avoided that.
Oh, it was a different issue then?
Yeah, so
The
Okay.
only way you could, for sure, avoid that is before you fabricate that new drive, you pull that existing one off, you make a template of that bolt hole pattern, and
Yep.
you take it back to your shop and you
Yep.
match it.
Yeah, and that was brought up, but most of our drive units take about 14 weeks to build. And so that's kind of where we can pull this old drive off, but then do you want to put it back on and hook it all back up? Or that's kind of where, what we could do, if there is a number 3, we could always sit down and think of, that 3-month start mark that you guys have to take it down for the coatings and all that. Maybe we could come out and do it right then. Leave everything how it is for the 3 months and try to get the drive done sooner. There's a lot of options that we could do.
That would be the most practical way to do it.
Yeah,
and I'll
and-
talk to Adam about including that in the design
Okay.
for a prefabrication requirement.
Yeah.
Is that and as soon as we're able to take that clarifier out of service, pull that and get a template, because to me that's the only way you'll guarantee that
Yep.
you'll be able to match that bolt hole pattern,
Yep.
and we won't have to ream holes and washer them.
Yeah. And, it very well could have been, going back and looking at my fabrication drawings from 1989, looking at my fabrication drawings for the new drive, everything looks like it should be perfect. So whether we missed it in an inspection, whether it got the column got fabricated a little bit different 23 years ago, I just don't know. And so yes, that would help hopefully eliminate that problem by doing that. We had that problem on this one. The last one, there was an issue with the ears, the cage ears on our old drives were much more shallower than they are now. So there was a problem where SandCon had to cut it about 3 inches off. This time we were able to implement that. So I really did spend a lot of time on this one, making sure that all the problems we had previously were handled before.
This one was definitely a lot smoother.
And we learned that the drawings from 1989 lie a lot.
Okay.
They all lie. So this one, and Brian, you can correct me if I'm wrong, I'm pretty sure the ducking skimmer part went in a lot smoother. There was the one hiccup with the one pipe.
It
and
looks
that was,
great.
Yeah, and that was just a fabrication error. That wasn't a design error. So it looks a lot better.
It does.
And I really did spend a long time designing this one versus the old one. So ducking skimmers aren't used a ton anymore in industry. Elsewhere, we don't do ducking skimmers very much. So I actually had to go back to a guy who's been at WESTECH for 34 years and say, help me understand what we're doing here. So I actually went back to one of our head designers and said, you do it this time. Help me out. Help me understand. So this one I'm a lot happier with. Anything else? So I'll get you a copy of this presentation, a PDF. Is that okay?
That's great.
Okay. I'll get you some information about who to contact about possibly algae problems. The other thing that might be great to do is our cells. So we have Misco Water who reps us, but we also have back in Salt Lake a group of guys that are in charge of all of our cells. They love to go out to plants. It may not be a bad idea to have him come out. His name is Greg Payne. I'll get him in touch with you. If you could leave me one of your cards,
Okay.
that'd be helpful.
Just go through Don.
Okay.
Since this project.
Okay. He would be great to just stop by, chat with you. He's really knowledgeable in a lot of this stuff. So, a lot smarter than I am.
Might do a lunch and learn with our operations and engineering department.
Okay.
Because obviously, we're hinging on a weir washer system working, but if it isn't, we need to look at other options.
Yeah, and like you said, the covers, some people love them, but other people really hate them. I don't know if there's a right answer. Maybe you could try. You have 3 different clarifiers. Try one and one on the other, one on the other, and eventually you might figure it out. I don't know. I wish I had a better solution for you. They're just nasty.
Maybe we'll look at the future ones too. Maybe we'll look at going to the beach.
Yeah.
If they perform as well and it's not a major cost issue.
So WESTECH has something called the COP Clarifier, and what that is a spiral blades versus the segmented blades, and then also we have a sludge withdrawal ring. So instead of having that arm and that manifold that fully rotate, we actually have a fixed sludge ring that goes out about 10 feet, maybe 12-foot diameter, depending on the size of the tank. And the spiral blade will actually move all the sludge, and then it has orifices inside this ring that will pull it out. And we actually have test data and some experience with these, and they actually work better or just as good as suction headers. And there's less maintenance because you don't have a moving part. Your ring stays stationary, and then you have a spiral blade that's continuously pulling sludge in on both arms. So that's always another option to help with that sludge. Now, if you still have a lot of scum, you can always look at doing a bigger scum box. I mean, the rotating scum pipe, right, those are great because they span the whole thing, but maybe a 6-foot scum box would work with an ARB baffle, something that helps scissor it all out. Sometimes, in my experience, you don't need a full radius scum box. You can usually do a 6 or 10-foot scum box with an ARB baffle that will work just as good with less maintenance, less moving parts, a lot of those things, especially where you don't have the freezing. I mean, does it ever freeze here?
No.
Okay, so freezing is where you really get a big problem with sneaking. So it doesn't look like you guys have too bad of a scum issue, but you certainly have some.
In the wintertime, when it gets cold, we have
More
issue foaming at this place and up north in the other facility.
All right.
Right. Anything else? Okay.
Tim, thank you very much.
Yeah, that's.
You guys could just do the O&M manuals with me, or get those logged in and distributed. Thank you.